Hello everybody, Harry from GMAT Ninja here, and welcome to the next episode in our GRE Quant series. In this video we're going to be taking a look at statistics, but as you can see from the part one I've got written up behind me, we've split the statistics into two, and so I'm going to be looking at the first half, or what we might call the first half in this video. Now what that means is we're going to take a look at how the GRE talks about and uses means, medians, and ranges in questions. Now, I'm not going to look at exactly how to calculate the mean, how to calculate the median, or how to calculate the range. I'm going to have to assume that you know what those things are. So if what I've just said is a bit of a mystery, I'd pause the video here, go and look for how to calculate means, medians, ranges, and then come back and we'll look at how the GRE can incorporate those into the questions. We're also going to take a look at mixtures. Now, you might have heard these referred to as weighted averages problems. They've got a couple of different names depending on who you're speaking to, but we'll take a look at one of those questions and look at a method for solving those. We're going to take a look at min-max problems. So how do I maximize the smallest value in a list, or how do I minimize the maximum value in a list? And then throughout, we're going to be looking at algebra hidden within statistics. So questions might look like a stats question, but really they're just an algebra question. And once you get an understanding of what the question is asking you to do, it turns into another one of these algebra questions that the GRE does so much. All right, so I've got 6 questions for you in today's video. Really, the first few questions are not going to be that difficult. So if you're aiming for something up to a 150, maybe a 155, we're going to have something for you here. If you're looking for something in the sort of the 160 plus range, those first few questions are probably going to be relatively easy for you. But in the last couple of questions, we're going to try and ramp the difficulty level up and hopefully challenge you a little bit towards the end. But if you're looking for something in the 165 plus range, 165 to 170, I probably don't have a huge amount for you here. This video isn't designed to get that difficult. All right, so with that, I'm going to get the first question up on the screen. As usual with these, I'm going to give you a minute 45, maybe a minute 45 to 2 minutes to take a look at the question, and then we'll come back and look at it together on the board. All right, I'll get the first question up just now. Best of luck, and I'll see you back here in a couple of minutes' time. All right, as always with these videos, if you'd like a little more time to have a look at this question, now's your chance to pause the video, but I'm going to take the question away so that we can work it through on the board together. All right, as I said in the introduction, I've got to assume a bit of knowledge at the start of this. So I'm not going to take a look at how to calculate the mean or how to calculate the median from just a simple list of numbers. If those are things you don't know how to do, I'd pause the video here, go away and find that information, and then come back to us. What I'm looking at here is how the GRE can take those basics and extend them up into GRE style questions. So we've got the first one here. We are given a table, and we are told that this table shows the frequency distribution of the random variable x. And as it's a quantitative comparison question, I want to know which is larger, the arithmetic mean of the values of x or the median of the values of x. So the first layer of difficulty here is just the wording of the question, and then it's the fact that we've got a table here. So lots of people don't like this wording, random variable x. Lots of students just freeze at that point. Now, that random variable x doesn't really mean anything technical. It just means that we've got something with a little bit of uncertainty going on. We've effectively run an experiment where the outcome can be 1, 2, 3, 4, or 5. And this is the number of times that I've got each of those outcomes. So this could be something like number of puppies in a dog's litter. The mother dog either has 1, 2, 3, 4, or 5 dogs, and 8 of those mothers had 4 puppies, 5 of those mothers had 3 puppies, something like that. Or we could say that this is, I don't know, the results of a game where you can score 1, 2, 3, 4, or 5 points in that game. And 3 people have scored 1 point, 10 people have scored 2 points, something like that. So you can think of this table, you can think of the random variable x as just something that has a bit of uncertainty to it. Now, the table is just a way of representing the data. Like I said, so let's go back to that game example. I've got a game and you can score 1, 2, 3, 4, or 5 points. In this case, 3 people have scored 1 point, 10 people have scored 2 points. So you could represent this data as a list, and it would look something like I've got 3 1s, and then I'd have 10 2s, and then I'd have 5 3s. And you could just list the data out like that. The table's just a nicer way of doing it. So as is often the case with these GRE questions, they're going to use the basic principles about finding a mean, in this case, or finding a median. And we're just going to extend the difficulty a little bit by using not always commonly used terms. Random variable x is not a commonly used term, but it just means something that can vary, just something that has a bit of uncertainty. And the table way is just a neater way of listing out longer lists of numbers so that I don't have to list out a load of things here. So what happens when I want to calculate the mean and the median from a table is the principles don't change much from if this was just a list of numbers. So I'm going to do the median first because it's a bit simpler. And the median value is just going to be the value in the middle. So if we lined them all up, if we lined up all the data in a nice line, I want the middle value. So first job that we need to do here is figure out how many values we have. And we do that just by adding up the numbers down this frequency column. So 3 plus 10 plus 5 plus 8 plus 4 means that I've got 30 values in total here. All right, so just like you would do if these numbers were listed out, I want to take that number, I'm going to add 1 to it, so 31, divide that by 2, 15.5. So I'm looking for what's in the middle of the 15th and 16th number in the list. Okay, so working down my list here, I've got 3 values in the first one. Then I've got another 10. So if I listed out these numbers in order, I'd have 13 values, 1s and 2s. Then I could move to the next row in the table. I've got another 5. So the 3s will be the 14th, 15th, 16th, 17th, and 18th values in my list. So I'm looking for the middle of the 15th and 16th value. Well, if I listed these values out in the table, the 15th value would be 3 and the 16th value would be 3. So the number right in the middle of the 15th and 16th value would also be 3. So we can say the median value of x here is equal to 3. All right, so find the median, exactly the same as if these were just listed out. Figure out how many numbers you've got, add 1, divide that by 2. That'll tell you which value you want, and then just work your way down the rows in the list until you have, in this case, the 15th and 16th value, and I want the one in the middle. And so finding the median from a table, not that much different from if it was a list. All right, finding the mean next, that involves a little bit more work here. All right, so it might go back to if this was just a list. What I would want to do is add up all the numbers in this list, and then we're going to divide it by 30. Right, so I could, if I had all the time in the world, list out all the numbers as if this was a long line, add them up, and then divide them by 30. But I want to do something a little bit more efficient than that. And so what we can say is, look, let's go back to the points in the game. If I score 1 point or 3 people score 1 point, then the total number of points scored is the frequency times by x, 1 times 3, which will give me a total of 3. And I just do that for every row. 10 people score 2 points, so 20 points were scored in total. 5 people scored 3 points, So 15 points were scored, and I'm hoping you're seeing the pattern here. 4 points were scored by 8 people, so we get 32 there, and 5 points were scored by 4 people, so I get 20 points there. Now I've just got to go and add these up. So 3 plus 20 plus 15 plus 32 plus 20, 52, 67, 87, 90 is going to be 90. And so the total, if I added up all the numbers in the line, is going to be 90. 90 divided by 30 is going to give me my mean. 90 divided by 30 is going to give me 3. So the arithmetic mean of the values is going to be 3. The median of the values is going to be 3. So in my quantitative comparison question, both the values are the same. And so the answer here is going to be C. All right, so like I said, I'm not going to go through just how to calculate the mean or how to calculate the median from just a normal list of numbers. I'm hoping that you understand how that works. But table, as soon as the numbers are thrown into a table, lots of my students, they just freeze. And so hopefully that has shown you that finding the mean or finding the median from a table isn't that much more complicated than finding it from a standard list of numbers that you're used to. There's a little bit more to it than just if it was a list of numbers, but the principles are the same. And if you can keep your head and just work through the problems, they're not going to be that tough. All right, so first question out of the way, we're going to stick with means and median, or stick with means, the idea of means, for another question or two. So I'm going to get the next one up on the screen, give you another minute and 45 or so to take a look at it, and I'll see you back here soon. All right, now's your chance to pause the video if you want some more time to look at this one, but I'm going to take that question away so that we can work this one through together. All right, so this is one of those examples of a question that the text, the length of the text and the kind of the way the question's asked can make people freeze. And what I want to focus on here is if we can stick to the principles of what we're doing, we've got a good chance of answering this one. The actual work behind it is not that difficult. We've just got to figure out what's going on here. So I've got 2 lists, and I've been told the average of those 2 lists. And I know the number of items in each of those lists. And I want to take those lists, push them together, and then find the average of the combined list. So first job, what I want to do is take a step back and just look at this principle here. We're looking for the average of 2 lists. So the average, well, that's just the sum of the items in the list divided by the number of numbers we have. So I'm going to take this bit and jump right to the bottom and say the final step that I'm going to be looking for, I'm going to find this average by finding the sum. We're going to find the sum, the total of the numbers in these 2 lists, and that's the problem. That's what we're working on in a second. And then we're told how many numbers are in the list. So this n value, the number of items in the 2 combined lists, is going to be 150. And I just need to find that value and divide it by 150. Now, this is the bit where people's heads start to go haywire. If they freeze, they may just begin to panic. And when you panic, you do really funny things. And one of the most common things that I've seen people do with a question like this is to say, well, the first list has an average of 65. And the second list has an average of 35. So if I just add those two numbers together, 65 and 35 is 100, and then I divide them by 150, that'll be the average. And that's why we've got 2/3 as an answer choice in here. Remember, the average, the overall average we're looking for is the sum of every number in the list divided by 150. It's not just going to be the sum of the two averages pushed together. We've got to do a little bit more work than that. So what we can do here is almost work this list backwards. So I'm looking for the sum of the numbers in both lists. And what I'm going to do is find the sum of the numbers in each list individually. Now, if I just rearrange this formula here, the sum of the numbers in the list is just the average multiplied by the number of numbers. And I've been given that for both lists. So the sum of list number one, well, the average of the numbers in list number one is 65. And the number of numbers in list number one is 25. And so 65 times 25 at this point in the GRE, get your calculator out. 65 times 25 is going to be 1,625. And we can do a very similar thing for the second list. The sum of the numbers in list number two, well, we're told that the average is 35 and there's 125 numbers. And again, get your calculator out. 35 times 125 is going to be 4,375. So the sum, the bit that I want to put on the top of this division, is going to be 1,625, the sum of the numbers in list one, added to 4,375, the sum of the numbers in list two, and that'll give me the sum of the numbers in both lists. So adding those both together, again, calculator out if you need to, but adding those together, I'm going to get 6,000. 6,000 divided by 150 is going to give me an average of 40, which means the answer to this question is going to be C. So, like I said, using very basic principles for this. The mean, if I'm being very precise with my wording, the mean is just the sum of the numbers in the list divided by the total number of numbers in the list. And in this question, you were given everything you needed in order to find the total sum of all the numbers in both combined lists. This is one of those questions where the length of the text, just the look of the question, makes it look much more intimidating than it is. So if you can stay calm and remember the principles that we're working with, these questions actually fall out okay. All right, so next question, we've dealt with, or we've had a look at how the GRE might use means. First question, we looked at medians. Now I'm going to take a look at a weighted averages question. And so it's just how another way of combining two data sets. So we'll get this up on the screen, give you about a minute 45, and we'll see you back here soon. Okay, I hope that's been enough time there, but I'm going to take this question away so that we can look at this one together. Now, first thing, another one, huge, great long wall of text here. And in questions like this, one of the temptations is to try and read quickly so that you can get through the text and get your pen and paper and start working. In a question like this, I would almost advise against that. a lot of the difficulty is going to be interpreting the question, what it asks for, and the amount of work you're going to have to do at the end is probably not that much. So whenever you open up a quant question on the GRE and see a question like this, please don't be tempted to just start racing through it, because that's just going to massively increase the chance that you misread it or misinterpret it or miss a piece of information. That's going to make things so much harder when you get to the working. Take your time. We're going to break this question down, have a look at it, see if we can understand it, and then we're going to get into the not very big amount of work we've got to do at the end. All right, so this question, if you have read it, you'll probably notice it's quite similar to the last question. We've got two groups. We know the average of both groups, but this time we don't know how many sheep are in both the flocks. Last time we knew how many items were in the first list and the second list. This time we don't. So we've got the averages. This time we know the average, the overall average, which we didn't know last time. And now I'm looking for a fraction. I'm looking for what proportion of Farmer Giles's overall sheep flock belongs in his second flock. So this is a weighted averages question. This is a mixture question. I've got two groups, I'm mixing them together, and I've got an overall average. When you see and recognize a question like this, what I would do is set yourself up with a bar diagram like this. All right. We know the overall average, that's 65 kilograms. So the average here, now I know I've put it in the middle and it's not really in the middle, but that's not going to matter a huge amount. We'll get into the details of why in a second. So the average, 65 kilograms. The first flock, well, that has an average of 62 kilograms. And the second flock, that has an average of 67 kilograms. Now, just as an aside, one of the things I'd suggest you ask yourself as you're doing this is which side is closer to the average? Because that's going to tell us that there are more. In this case, the second flock is closer to the average than the first flock. So there are more in the second flock. I'm just going to tuck that piece of information away for now. We're going to use that a little bit later. But know that there are more sheep in the second flock. All right, the next job here, once we've got this bar drawn, is I want to know how big of a gap there are between the average and between the two sides. So if the average is 65 and the first flock is 62, then there's a 3 kilogram gap between the first flock and the average. And similarly, between the average and the second flock, there's a 2 kilogram gap there. So what I can say about the situation here, if I set up a ratio first to second, then the ratio of the gap between the first flock and the average and the average and the second flock is going to be 3:2. Now that ratio might need to be simplified. We could have had something like 9:6. We simplify it down to 3:2 here. And this is the ratio of the gap. Now, the reason I'm making such a big thing of this is because there's one more step to do, and I don't want you to forget that second step. So this is not the ratio of the number of sheep in each flock. Remember what we said, there are more sheep in the second flock, so the ratio can't be 3:2 first to second, right? What there is, the final step that we need to go through is to say, I'm going to build the ratio again, first to second. I'm going to take that 3:2 and reverse it, 2:3, and this is now the ratio of the numbers. This is the ratio I'm looking for. So I know I'm making a big thing of this, but very important, don't forget this. That final step, when you find the first ratio, that's the ratio of the gaps, and you need to reverse that ratio to find the ratio of the numbers. Now we know that the ratio of the sheeps in Farmer Giles's first and second flock is 2:3, and we can go and answer the final question, what fraction of Farmer Giles's sheep belong in the second flock? Well, I know that there are 3 parts in the second flock, and there are 5 parts in total. So in the second flock, that's going to be 3/5 of the total, and coming across to my answer choices, that's going to give me an answer of D there. All right, so I know weighted averages, I know there are algebraic methods, and if you are somebody that likes the algebraic method and it works for you, great, stick with it, wonderful. What I tend to find is that when the pressure is on, the time pressure in particular, let's say it's question 19, you got 45 seconds left, you've got 2 questions left to go, you've not managed your time brilliantly, but you've got a mixtures question and you need to get through it. then that time pressure does funny things to your memory and people muddle up the terms in the formula here. This process, if you remember that final step of reversing the ratio to move from the gap to the numbers ratios, this process tends to be a little more secure in people's memories, which is why I prefer this method over memorizing the formula. So when you've got a mixtures question, a weighted averages question like this, you can use this bar method, find the ratio of the gaps, reverse that ratio, and that'll find you the ratio of the numbers. And it's a relatively quick and easy to remember process that is going to get you through these questions effectively and, most importantly, minimize your chance of making an error. All right, so I hope that was helpful for mixtures questions. We're going to keep this going. We're now going to move on from averages, and I'm going to take a look at range questions. So it's still hopefully not too difficult a question. We're not going to look at how to calculate a range, but how the GRE might use these. So another load of text in the question. As we said with this one, take your time, read it carefully. I'll see you back here in a little under 2 minutes to go through the next question. All right, now's your chance to pause the video if you want some more time to look at this one. But I'm going to take the question away so we can look at it together. All right, so last few questions, we dealt with means, we dealt with medians, we've had a look at those weighted averages questions. Now we're onto ranges. Now at its most simple, the range is just line the numbers up in a line, take the biggest one, subtract the smallest one, and the number you get there, that is the range. That's the gap between the biggest and the smallest number. Now, we're not going to go through just how to calculate that because that's really all there is to that. What we're going to look at is how the GRE could ask you a question about the range, using the range, and throw a couple of wrinkles in here to make it a little more difficult. So what we've got in this situation is that I've got two groups of workers and I know the range of their salaries. I don't know what their salaries are. I don't even know where they are. I don't know the smallest. I don't know the largest. I don't know anything except the range. So for the first group, the range is 25,000, and for the second group, the range is 35,000. And I'm asked which of the following, and here's the important word, which of the following could be the range of salaries of workers from both groups combined. So we're looking for anything possible, whatever the range is. If it's possible, we're going to take it as an answer choice because we've got one of these questions that says select all that apply, so we can have more than one correct answer. So what I'm going to do to begin with is just take a start point. Right, I'm going to make the numbers nice and easy, and I'm going to say, look, my bottom salary, I'm going to say is 20,000. Right, and so I'm going to take the group of workers from building A, and I'm going to build a bit of a bar here. Now, I know that the range of their salaries must be 25,000. And so if the smallest salary is 20,000, then the biggest one is going to be 45. Right, now, if I give the same start point to the second group, they're also going to start at 20,000, but their range is 35,000. So smallest one, 20,000. The range is 35, so the top one is going to be 55,000. So both of these groups, completely arbitrarily, I don't know if the smallest salary is 20,000, but that doesn't really matter. I'm just saying, what if it is? Then I've put the first group here, the second group there. Now these bars, the important bit is the bars themselves can't stretch and they can't squish. So if I look at the overall, if I combine these two, then the smallest salary is going to be 20,000. And the biggest salary of the combined group is going to be 55,000. And so the total range of the combined group is going to be 35,000. And because I can't squish these bars, I can't make them any smaller, that's the smallest possible value for the range of the salaries of both the groups combined. So looking at the answer choices, A and B can't be the right answer because there's no way I can take this 35,000 group and squash it in. So this setup that we've got here, okay, I know I've picked the numbers arbitrarily, but you could take everything and shift it to the left and shift it to the right. If we're just focused on the range, the smallest that the range of the combined salaries can be is 35,000. All right, now we can take a look at, well, could we make it any bigger? I'm going to leave the workers from building A where they are, and I'm going to choose, again, I can make this choice because I don't know anything about the groups. This is just completely arbitrary. I could choose to start the workers from building B. Let's just start them on, I'm going to start them on 30,000. And they've still got a range of 35,000, which would mean that the top end, that's going to be 65,000. And now, if I do the combined group, that's going to go from 20 all the way up to 65. And so the range is going to be 45,000. And so like I know that C and D is in. Those can both be answer choices because we've shown that they can both work. But again, 30,000 was picked completely out of the air. There's no reason behind that. So why don't I keep going? There's nothing to stop me, theoretically, from starting group B. Let's start them all the way over here and say that that's 100,000. Again, there's nothing stopping me doing that. I'll have a bar. The range is still 35,000, which means the top end could be 135,000. And now, if I do my combined bar, the range is going from 20 all the way up to 135. Well, now I've got a range of 115,000, which is bigger than any of the options. And so all of these are possible. And since the question is which of the following could be the range, well, all of them. So C, D, E, and F are all correct answers here. Now, theoretically, these bars can keep going further and further apart. I mean, I could pull this bar down so that the poor person who's got the lowest salary could be down on $1. And equally, the top end, and that could be way over there up in the millions. Theoretically, there is no maximum gap that we've got here, as long as I can keep stretching these bars further and further apart. But at the minimum end, because I can't squash the bars, the smallest the range can be is the smallest the combined range can be is the bigger of the two individual ranges, in this case 35. So A and B can't be an answer to this question, but C, D, E, and F are all correct answers, and you should select all of them to answer this question. All right, so ranges, especially when you're asked to combine them, it's helpful to think of them as bars that you can't squash or stretch, but you can shift the bars left and right, and using that way of thinking can help you get through questions like this. All right, next question, and we're going to start to try and increase the difficulty level a little bit. This one, we're beginning to stretch you a little bit, but not a huge amount here. We're back to dealing with averages. I'll give you a couple of minutes to take a look at this problem. I'll see you. All right, now's your chance to pause if you want more time to think about this one, but I'll take the question away so we can look at it together. All right, question like this, the temptation is to jump to D immediately, because what I'm asked for, the average arithmetic mean price of the 30 cars versus 6,500 in a quantitative comparison question. Now, admittedly, I'm not going to be able to find the mean price of the 30 cars. I've been given ranges. I know 10 of them were sold between 4,000 and 5,000, and 20 of them were sold between 8,000 and 10,000. So I'm not going to be able to put one number on what the average is. But maybe we can get a bit more information from this. So that, like I say, the temptation is to jump to D, but let's do a bit of digging before we confirm that. There's a bit of thinking to do first here. So what I can do is figure out, well, what's the minimum value of the mean? So if I take this, if I just assume, and I know this didn't happen, but if I assume that all the cars were right at the low end of both of these ranges, so then I would say the dealership sold 10 cars for $4,000 each, and so the total was 40,000. And they sold 20 cars at $8,000 each, giving a total of 160,000. And so add those numbers up. At the low end, this dealership sold all the cars for a total of 200,000, and there were 30 cars. So if I divide that number by 30, I'm going to get an average value of 6,667. Yeah, okay, 66666 recurring, but let's just round it because we don't need to be precise here. And look what happens. The minimum value of the average, well, that's already bigger. It's already bigger than the other one we're looking for. So yeah, I don't know what the average is. If we went on, you can do a very similar thing and say, what's the maximum value of the mean is? And you can do the same similar calculation, taking 10 of cars and putting that at the top end. So 10 times 5,000, 20 times 10,000. And so we're going to end up on the maximum end with a total sale value of 250,000. And again, I've got 30 cars there. So doing that division is going to give me an upper end average of about 8,300. Now, again, in this question, you don't need to have done that second bit. I'm just doing it to make the point here. I don't know the average price of the 30 cars, but I know it's somewhere between $6,667 and $8,300. It's somewhere in that range. Now, the question says, which is bigger, the average or 6,500? And because the range that I'm looking at starts higher than 6,500, quantity A is going to be bigger than quantity B, and my answer for this question is going to be A. So like I said at the start, the temptation is to go for D because you're not going to know what the average is, but I don't need to know the average precisely in order to answer this question. Depending on the question, it might be more helpful to find the minimum. It might be more helpful to find the maximum. In this case, I wouldn't have needed to find the maximum, find the minimum first. I know that's already bigger than quantity B, so the average is already going to, or whatever it is going to be bigger than 6,500, and I'm done. In other questions, depending on how they're worded, depending on how they're framed, it might be more sensible to find the maximum value of the range first, and that might give you enough material to answer the question without finding the minimum. And in some cases, you're going to need to find both. So the way we got around this, we were given a range of values for, like we said, 10 cars were sold between 4,000 and 5,000. For the minimum, I just assumed that every car was at 4,000. I know it wasn't, but that's how I'm going to find my range. Find the maximum by just assuming every car was sold for the top value in that range. It wasn't, but that gives me the information I need to build the range that the average could be, and that's enough to answer a question like this. All right, I got one more for you today, and now we're really going to bring the algebra into one of these statistics questions. This question's designed to be a bit more challenging, so if your target on the GRE is anything up to a 160, I'd expect this one to be very tough for you. If you're aiming for something over 160, hopefully you can have a good shot at it, and you 165 plus people, yeah, I'd like to think this will challenge you, but you should be able to handle this one. All right, so we'll give you a little bit of time to take a look at this problem, and I'll see you back here to go through the final question for today. Okay, plenty of text to read and quite a bit of algebra to do. So if you want a bit of more time to think about this one, pause the video here and we'll still be here when you finish working through it. All right. So like I say, lots of text. And again, please don't rush through it. There's quite a lot of information here that we're going to break down. And as we walk through this question bit by bit, you'll see that the opportunities for slipping up are all over the place. So please, when you get a long question like this, please be careful. Don't rush through it. Take your time, read it carefully. We can get to the algebra later. All right, so this question tells us, we're going to go from the beginning. We've got 7 pieces of rope. And we're told they have an average length of 54 centimeters. So go back to that second question. What we were talking about is the average is equal to the sum multiplied by the number of numbers. Well, in this case, I know the average, I know the number of numbers. I can find the sum from this one. And so if we rearrange that, the sum is going to be the average times by the number of numbers. So our average is 54, our number of numbers is 7. And if we do 54 times 7, we're going to get 378. So if I have my 2, 3, 4, 5, 6, 7 numbers, and I added them up, whatever these numbers are going to be, the sum of those numbers is going to be 378. All right, so we've dealt with the first part of the question up to there. I'm just going to keep working through bit by bit. These 7 numbers have a median length of 72 centimeters. All right, so because it's an odd number, I'm told the median. Well, I know one of the values then. In this case, the 4th value in this list is going to be 72. That's nice to know. I've now got a piece of information in there. Okay, now, again, working through the question, we've dealt with the first sentence. So the next bit says, if the length of the longest rope is 12 centimeters more than 3 times the length of the shortest piece of rope. Okay, now we're setting up some sort of equation. I'm just going to put a value in for the shortest piece of rope. Let's call that x. Could pick any letter, but let's just choose x. Now, the length of the longest rope is 12 centimeters more than 3 times the length of the shortest piece of rope. So 12 centimeters more, I'm going to add 12 to 3 times the length of the shortest piece of rope. So this longest one is going to be 3 times the length of the shortest piece of rope plus 12. Okay, so I've now, I don't know the numbers, but I've got some relationship between the smallest and the largest piece of rope. And working through the question again, I've dealt with everything up to this final bit. Now we can take a look at what the question's actually asking. What is the maximum possible length of the longest piece of rope? So I want to take this longest piece of rope and make it as big as possible. I'm trying to maximize that. Now, in these sorts of questions, whenever the GRE asks you to maximize one value, don't look at that value to begin with. All right, it's a bit like a magician when they're waving a hand saying, look over here, really the trick is going on over this side. So I want to maximize the longest piece of rope. And to do that, I'm going to make everything else as small as possible. All right, so over on this side, these bottom 3, if x is the smallest possible length of any rope, well, then I can make the next 2 the same as that smallest value. All right, so bottom half, x, x, x. Then I hit the median. I was told that was 72. Now, the next 2, I still want to make these as small as possible. They can't be the same as x. Well, they could be, but very unlikely. They could be the same as the median, but they're probably smaller. I couldn't put these 2 in as x because I don't know if x is the same as 72. What I could say is that these 2 values could be the same as the median. They could also be 72. That's the smallest they could be. And so now I've minimized all of these, the other 6 values, which means that this largest one will be as big as possible. So as I said, whenever you're asked to maximize the longest piece of rope, I want to make the others as small as possible. And the reverse, if we were asked to make the smallest one as small as possible, I would make all the others as big as possible. Okay, so we've got something set up here. I've now got what is beginning to look a bit like an equation. X plus x plus x plus 72 plus 72 plus 72 plus 3x plus 12 equals 378. And I can begin to simplify this equation a bit. So I've got 3 x's, I've got another 3 x's, so that's going to give me 6x. 72 plus 72 plus 72 is 216, plus another 12, 228. That equals 378. Now I can just go and solve this equation. 6x is 150, and x equals 25. Right? Now be careful. what is the question asking us for? I want the maximum length of the longest piece of rope. That's not X. The temptation here is, because I found an X value, X is an answer in the answer choices, to just jump at this, go, great, I finished, move on. No, this isn't what we were being asked for. The maximum length of the longest piece of rope is 3x plus 12. So if x is 25, 3x is going to be 75, and 3x plus 12, which is what we're looking for, is going to be 87. And so the answer to this question is going to be D. So that little bit at the end there, it's just so tempting if you set up an equation in a question to figure out what X is and to jump at one of the answer choices. But be careful. Have another read of the question just to confirm that you have actually answered the question that was written. What were we asked for? The maximum length, the longest piece of rope, and that took an extra couple of steps to get to at the end there. All right, so I know there was plenty going on in that question, but what I hope you saw, just by breaking the text down bit by bit and just working through it, being nice and careful, we didn't misread anything. These long questions can turn into something that doesn't take too long once you get into the algebra. You've still got to be careful, but you can work it through within the time that you've got available. And then the other bit, remember the kind of the magician's hand trick. If you're asked to maximize the largest value, then the question's saying, look over here, but really you should be focusing on what's going down on the smallest ones, and vice versa. If you're asked to minimize the smallest value, you should be looking to maximize everything else in a question. All right, that's all I've got for you in the first half of the statistics video. We'll hopefully see you back here for the second half when we look at things like standard deviation, percentiles, and other ways of other parts of statistics that we've not covered here. I hope this video is helpful, and we hope to see you back at another one of our videos very soon. Thanks very much, everybody. Have a great day.